Hello everyone, this is Chandan and you are watching the learning field. Okay, so as promised, we take the class on classical mechanics first for the West Bengal SET exam 2023. The exam date is 8th January and we will try to cover some topics, some questions for WBSET. I already solved some papers of or solved the questions paper of 2020 WBSET, 2022 WBSET and 2018 WBSET questions paper, some questions. Okay, I think this is mostly solvable. These two papers are mostly questions are already solved, and I already solved I think 40 to 50 questions of 2018 paper. Okay, so all the concept and these solutions are available in the channel of the playlist. You can check the playlist West Bengal SET WBSET मैथमेटिकल साइंस करके एक प्लेलिस्ट है, ठीक है। तो वहाँ पे आप लोगों को वेस्ट बंगाल सेट के रिलेटेड मतलब बहुत सारे कंटेंट मिल जाएगा, ठीक है, मैथमेटिकल साइंस के। और पेपर 2 दिस क्लास इज आल्सो फॉर द पेपर 2 मैथमेटिक्स, यू ऑल नो दैट। Okay, so this is the class on classical mechanics. In this class we will cover the important topics and terms of classical mechanics, take some examples, and we will also solve some previous year questions of classical mechanics, and we will cover the important parts of classical mechanics because this is a very huge subject. Okay, very huge topic. I want to take the only important terms or important topics of classical mechanics and the regarding questions and examples. Okay, and also the previous year questions. So I think this class will be very helpful for you for the West Bengal SET exam aspirant of 2023. Okay, so watch the video till the end, and one more request is that those who are new in my channel for the first time, please like the content. If you like, then please comments. If you if you don't understand, then comment me in the comment section below. And if some topics or I skip some topics and you think that these topics are important but I skip that topic, it may be happens, then also you can comment me in the comment section below, and obviously subscribe the channel. Okay, so let's start. So first, the main important thing is constant. Okay, in the classical mechanics, so what are the constant? So it says that the motion of a particle or system is restricted by one or more conditions. The limitation on the motion of a system are called the constraint, and the motion is called the constraint motion. Okay, suppose we have a system of capital N number of particles with Ri with the position vectors of the position vector of the ith particle at time t. Okay, so let Ri dot equal to d dt of Ri be the here the derivative, all the derivative terms are the time derivative terms. Okay, so with the velocity vector of ith particle at time t. Okay, by a constant of mechanical system we mean a relation of the kind that is this such type of relation which is f of r1 r2 rn. This is the position coordinates, and r1 dot r2 dot and r2 dot, this is the derivative velocity vector and the time vector. Okay, this is the function type. Okay, we call the constraint finite or geometric constraint if and only if it has of the form f of r1 r2 and rnt, this is equal to 0. That is, if this function is free from the derivative term or velocity vector, free from the velocity vector, then we call it is a finite constant or geometric constant. Okay, now holonomic constant. What is holonomic constant? And one more thing is that you can comment me if you need this PDF, then you can comment me. I will share the PDF in my Telegram channel. Okay, you all get the link in the description of the Telegram channel, the learning field. Okay, you can join the Telegram channel for your future reference, for any discussion, for any comment, or for any content. Okay, so a constraint is called holonomic if it is not subject to a differentiable non-integrable constant. Okay, now one more example of a holonomic constant. All free system, finite or geometric constant are types of holonomic constant. Okay, otherwise a constant we call a constant as non-holonomic constant, that is the constant which are not holonomic, we say that non-holonomic constant. Okay, if there is another type of constant. Okay, if a constant is explicitly independent of time, then it is called the scleronomic constant, and otherwise the constant is called the rheonomic constant. Okay, now one more important term is the degrees of freedom. Okay, here in the mechanics this is very important term, degrees of freedom. So it says that the minimum number of independent variables, just a minute, this pen I think very, so variables or coordinates required to specify a position of a dynamical system consisting of one or more particles is called the number of degrees of freedom. That means what? Suppose any mechanical system occurs, or there are any mechanical system in any space or any the number, here the coordinates or space coordinates are very important. Okay, so degrees of freedom means what? For if we here it says that the minimum number of independent variables needed to specify the position of a dynamical system. Okay, so this is called the degrees of freedom. For example, the motion of a particle moving in free space, moving freely in space, can describe by a set of 3 coordinates. Okay, that means what? The degrees of freedom is your 3. Okay, so this is the example. You can consider the simple harmonic motion also, the spring also, the string also, this type of motions also. All the system has a free has a degrees of freedom. Okay, suppose if you take the this type of motion, I think pendulum, simple pendulum, then there is only one degrees of freedom, which is theta. You see that the motion of the simple pendulum is based on only theta. There is a there is a variable which is theta. Okay, that's why the simple pendulum, I think, yes, simple pendulum has the degrees of freedom 1. Okay, so this is the example. Now it says that if a system consists of n particles moving freely in space, we need 3n independent coordinates in general to describe its position. Hence the number of degrees of freedom of the system is 3n here. Okay, now one more important thing is that generalized coordinates. Okay, so what is the generalized coordinates? Suppose we have a holonomic system of n particles with Ri with a position vector of ith particle at time t. Okay, suppose the system has n degrees of freedom, okay, where n less than 3n. Therefore we need n number of independent parameters to describe the mechanical behavior of the system. So let q1, q2, qn are the n independent parameters. We call them as a generalized coordinates of the system. Okay, so this is the definition of generalized coordinate. Now generalized velocity, qk dot equal to ddt of qk. This quantity is known as the generalized velocity of any particle of any mechanical system. Okay, so now total kinetic energy of the system T equal to summation I equal to 1 to n half mi ri dot into ri dot. These are the vector quantities because these are the position vectors. This ri is the position vector of the ith particle and ri dot is the velocity vector of the ith particle. Okay, so this is the kinetic energy. Now we comes to another important term, which is generalized forces. Here qk, a capital qk equal to summation I equal to 1 to n fi into dri dqk. This quantity is known as the generalized forces. Okay, now general form of Lagrange's equations. This is very important, and this is the most important thing of Lagrangian dynamics or Lagrangian mechanics. Okay, so ddt of del t del qk dot minus dt dqk, this is equal to capital Qk or k equal to n. This equation is known as the general form of Lagrange's equation. See, I think you all use these equations where in the calculus of variation. Okay, so the Euler-Lagrange equations, similar equations like this. Okay, ddt of the Euler-Lagrange equation is what? Ddt of del f del ddt of del f del y dot minus del f del y. This is equal to 0. I think this type of equations we read in calculus of variation. Xi may be interchanged. I just write these two variables here. Okay, so I think dy of, I think this should be dy of this, I think maybe this is okay. So Lagrange's equations for conservative system, this is very important. So ddt of del L del qk dot minus del L del Qk, this is equal to 0. You all must remember this equation, okay, Lagrange's equation for conservative system, where L equal to T minus B is called the Lagrangian. That means this L is called the Lagrangian, and there is a derivation of these two equations also, but I skip the derivation part, okay, because if we take the derivation part, then this video is going to very long video, okay, that's why I skip these parts for the derivation parts, okay, of the the derivation parts, okay. Now it comes to, and one more thing is that the some topics इधर उधर हो सकता है, ठीक है, तो मैंने क्या किया है, मैंने कुछ नोट्स इंटरनेट से मतलब जुगाड़ करके ना एक मेरे जैसा एक शॉर्ट नोट्स टाइप का बनाया हूँ, ठीक है, तो कुछ टॉपिक्स इधर कुछ टॉपिक्स इधर ये हो सकता है, तो इसलिए मैं पहले ही सॉरी बोल देता हूँ, ठीक है। सो क्योंकि देखो कभी कभी हैमिल्टनियन में मैं कुछ लैग्रेंजियन डायनामिक्स का कुछ टॉपिक्स मतलब यहाँ पे हो सकता है ऐसा, ठीक है, तो दैट्स वाई आई सॉरी फॉर दैट, but I think this class is very helpful, okay. These all topics are very important for the classical mechanics, okay. So for any magnetic system, the actual path of motion is such that for which the action integral has the stationary value, and action integral means what, if this t1 is some time and t2 is another time, okay, then this action integral is what, this action integral is s equal to t1 to tt L of dt, and L is a function of qk dot and t has the stationary value, okay. This is the Hamilton's principle in short, and one line principle you can say, and the some books use the word the very big or some another words of Hamilton in the Hamiltonian principle, you can also check that, okay. So here one another important thing is gauge invariance. So gauge invariance of Lagrangian is what, if L is the Lagrangian for a system of n degrees of freedom satisfying the Lagrange's equation, it can be shown that L dash equal to L plus df dt also satisfy the Lagrange's equation, f being an arbitrary function, okay, f being an arbitrary function, and this f is called the gauge function of the Lagrangian, okay. This is arbitrary function, but the function has a name also. What is the name? The name of the function is gauge function. Now one more important thing is that the symmetry properties of space and time and the conservation law. So from here the questions comes in 2022 WBSET exam, okay. This I think I already solved the question in the in the 2022 solutions paper, you can check that, that's why I does not take here the question, or I am not taking the question here, okay. So the homogeneity of time, one is there are three types of properties of space and time. What one is homogeneity of time, second one is homogeneity of space, and third one is isotropy of space, okay. So for any arbitrary displacement of origin of time, the physical or mechanical properties of any closed system remains unaffected. So this is the first symmetry properties, which is homogeneity of time, and the most important thing is homogeneity of time implies principle of conservation of energy. So based on this line, questions comes in WBSET 2022, okay. Just 4 statements given in the question, you have to I think identify what is wrong here or what is the right ones, okay. So these types of questions, this is very important for the exam purpose. And second one is homogeneity of space, this is called the translational invariance. So for any arbitrary displacement of origin of space, the physical or mechanical properties of any closed systems remains unaffected, okay. And the important line is that homogeneity of space implies the principle of conservation of linear momentum, and the third one is isotropy of space, and this is also known as the rotational invariance, and it says that for any arbitrary rotation of space, there is obviously the small rotation or arbitrary displacement here, small displacement, okay, and of space, the physical or mechanical properties of any closed systems remains unaffected, and isotropy of space implies the principle of angular conservation of angular momentum, okay. So these are very important concept for the West Bengal state exam, okay. Now it comes to another important thing, which is cyclic coordinate. What is the cyclic coordinate? Suppose the Lagrangian of a mechanical system does not contain a generalized coordinate explicitly, then such coordinate are called the cyclic coordinates. Suppose L is a function of L of q1, q2, qn and t. These are the generalized coordinates. Suppose qk is absent from the generalized coordinates, then we must have the del L del qk, this term is equal to 0. Okay, so by Lagrangian equation with respect to qk, this is the Lagrangian equation, we already see that. So ddt of del L del qk dot minus del L del qk is equal to 0. So we can write this is equal to del L del qk, and since del L del qk equal to 0, that means this term is also equal to 0. ddt of del L del qk, this is equal to 0. This implies del L del qk dot equal to constant. So this is the condition in case of qk is the cyclic coordinate. Okay, now corresponding to each generalized coordinates qi I equal to 1 to n, the quantity del L del qi is known as the generalized momentum. This is also very important, and we denote the generalized momentum as p suffix I or pk. You can take any suffix. Okay, so sometimes I use suffix k, sometimes I use suffix I. Okay, these are just the suffix. Okay, so that is del L del qk. See, here I use del L del qi dot, and here I use del L del qk dot. Okay, equal to constant, then pk is equal to constant. So this is the term, or this is the quantity of generalized momentum. Okay, now it comes to another important topic, which is Raudian. You have to calculate, or there is a questions to calculate the Raudian. Okay, this type of questions can be asked in our exam, West Bengal set. Okay, suppose out of n generalized coordinates, m which are less equal to n be the number of cyclic coordinates. Okay, without loss of generality, let q1, q2, qn are the cyclic coordinates. That means what? These coordinates are absent in the Lagrangian. Okay, then rest qm plus 1, qm plus 2 and qn are not cyclic. Then we can write del L del qk dot equal to constant. This is equal to, we take beta k for k equal to 1 to m, because since q1, q2, qm are absent, therefore these terms are constant. Then we can write summation I equal to 1 to n qi dot del L del qi dot minus L. This quantity is equal to r. Now r is a function of what? R is a function of q1, qm plus 1, qm plus 2, qn, and here the terms q1 to qm are absent. That is the cyclic coordinates q1 to qm are absent in this function, which is called the Raudian, and the expression is this one. Okay, but all the derivative terms or qk dot terms are present. That is, these are the velocity vectors. Okay, are present in the function, and also this is a function of beta 1, beta 2, beta m, and obviously in this is a function of time also. Okay, so r equal to summation I equal to 1 to m beta I qi dot minus L. This quantity is called the Raudian of the system. Okay, and where L is a function of this one. Okay, now Raudian equation. What is Raudian equation? ddt of del r del qi dot minus del r del qi. This is the Raudian equation, you can say, and where I equal to m plus 1 to n. Example. Okay, so what is the example? I take here the example, the kinetic energy. Suppose the kinetic energy T equal to q1 dot square by 2 into a plus b q2 plus half into q2 square into q2 dot square. Okay, and potential energy B equal to C plus D QT, where A plus B plus C, A, B, C, D are constant. Now if we want to calculate the Raudian, then we first form the Lagrangian, and you all know that the Lagrangian means simply T minus B, that is kinetic energy minus potential energy. So this is the Lagrangian. Now here it says that it can be seen that, or it can be noted that here q1 is absent in this expression. Okay, therefore q1 is the cyclic coordinate here. Okay, therefore del L del qk dot equal to constant, since q1 is the cyclic coordinate. So this is equal to q1 dot by a plus b q2. This is equal to constant, and constant equal to, we take beta. the beta case. Here since only one cyclic coordinate, therefore we don't need to give here the suffixes. Okay, so this is the fact. Now we calculate the Raudian. Okay, so Raudian equal to what? The Raudian equal to, this is the term beta I qi dot minus L summation I equal to 1 to m, and here since only one cyclic coordinate absent, therefore we can similarly write, or we can simply write beta q1 dot minus L. Okay, now this is equal to beta q1 dot minus, this is the expression for L. Okay, so beta q1 dot minus, this is the expressions. Okay, you can just simply write here, and we just put the value of beta. This is equal to what? This is beta equal to q1 dot by a plus b q2, q1 dot by a plus b q2 in the expression of L. Okay, then the expression of L in this term. Okay, we write this term in terms of beta. So you can write here this terms, it simply comes half minus half into beta q1 dot, and this and this. So this is equal to half into beta q1 dot. So this is we get. So this is the Raudian of the above system. You can also calculate the Raudian equations also. This is some big calculation, that's why I do not take here the example. This is just, you can put in the equation here and simply calculate the Raudian, okay, equation. Okay, now we comes to Hamiltonian mechanics and Hamiltonian of a mechanical system. Okay, the terms H equal to summation I equal to 1 to n pi qi dot minus L, where L is the Lagrangian of the system. That means what? If we know the Lagrangian of the system, then we can calculate the Hamiltonian also of the system. And we already get the questions in the WBSET exam to calculate the Hamiltonian. You just give or you just given the Lagrangian, or you can also in the exam you can also get the value of t and v given, and then you have to form the Lagrangian, then you have to calculate the Hamiltonian. Okay, so this is the case, and this type of questions can be asked in the exam. So this is the Hamiltonian and Hamiltonian equation of motions says that qi dot equal to del h del pi. That means if we know the Hamiltonian of the system, then we can also calculate the Hamiltonian's equation of motion of the system. Okay, so pi dot equal to ddt of del L del qi dot, this is equal to del L del qi, this is equal to minus del H del qi. That means what? This qi dot equal to del H del pi and pi dot equal to minus del H del qi. These two are the Hamiltonian's equations of motion of the given system. If the Hamiltonians are given, then we can calculate the Hamiltonian equation of motion for the system. Now if we take an example, so here I take the particle of mass m. Okay, so the particle of mass m in a potential v, where h equal to given, that is the Hamiltonian of the system is given here. Just a second. Okay, so if we calculate the Hamiltonian equations, then there are the coordinates are, that is the generalized coordinates are here x, y and z. Okay, that is what this qk, the qk are the generalized coordinates. That means q1 equal to x, q2 equal to y and q3 equal to z here. Okay, now if we calculate, and these are the momentums are the px, py and pz, that is pk's are the momentum terms. Okay, then px, py, pz are the momentum. Okay, so Hamilton's equations are x dot equal to del h del px. This is equal to, if we just simply derivative with respect to px here, we get 2px by 2m, that is px by m. Y dot equal to del h del py, this is equal to py by m, and this px, py are suffix. Okay, and z dot, this is equal to del h del pz, which is equal to pz by m, and px dot equal to minus del h del qk, that is here del h del x, which is equal to simply del b del x. Py dot equal to del b del y, because this function is not the function of x, y and z. Only this v function is the function of x, y and z. That's why here only we put the del b del z. And pz dot equal to minus del h del z equal to v del b del z. Okay, so these 6 equations is known as here the Hamilton's equations of motion. Okay, now here this questions comes in West Bengal set 2020. Okay, this is the previous year question. Okay, WBSET 2020. This is the X series. Sorry, this is the X series and question number 45. Okay, the question says that the Lagrangian of the dynamical system is L equal to this one, that is given L equal to q1 dot square plus q2 dot square plus q1 square, and p1 p2 are the generalized momenta corresponding to given generalized coordinate q1 and q2, then the Hamiltonian h of the given system or given by. Okay, so we have to calculate the Hamiltonian. So Hamiltonian's h means what? Summation pi qi dot minus L. Here two generalized coordinates, therefore I vary from 1 to 2. That is what? This is equal to p1 q1 dot plus p2 q2 dot minus L. Okay, now we can calculate the momentum term p1. This is equal to what? Del L del q1 dot. This is the momentum term, and we calculate from the Lagrangian. This is equal to 2 q1 dot, and p2, this is the second momentum, which is del L del q2 dot. Okay, this is equal to 2 q2 dot. Okay, now we put the values, and here in the four options, the options are in terms of p's, that is generalized momenta. That's why we change this p q1 dot and q2 dot in terms of generalized momenta. Then and before that we'll just put the values of L. So this is equal to p1 and just write together. Okay, so this implies from here we get what? q1 dot equal to p1 by 2, this one, and q2 dot, this is equal to p2 by 2. We just put here. So p1 into p1, I think, just a minute, p1 q1 dot, is, I think, so first we just calculate, then we write. Okay, so p1 q1 dot plus p2 q2 dot minus L means what? L means what? L means minus q1 dot square minus q2 dot square minus q1 square. Okay, now what? q1 dot equal to p1 by 2 and q2 dot equal to p2 by 2. We just put the values here. So p1 into what? p1 by 2 plus p2 into q2 dot means p2 by 2 minus q1 dot square means what? q1 dot square means p1 square by 4 minus p2 square by 4 minus q1 square. Okay, so this is equal to p1 square by 2 minus p1 square by 4. That means p1 square by 4 plus p2 square by 4 minus q1 square. So this is equal to 1 by 4 into p1 square plus p2 square minus q1 square. So this is the answer, and option D is clearly correct here. Okay, now go to the next question. So this is also the questions of WBSET 2020 paper. Okay, the question says that if the Hamiltonian of the dynamical system is given by h equal to p1 q1 minus p2 q2 minus this term, then where a b are constant, then what? Then this value is what? We have to calculate. That means what? We have to first calculate the value of p2 and q2, then put the values here. Okay, now see the answer of the question. So here given that Hamiltonian. Okay, so Hamiltonian given, that means we calculate here the Hamilton's equation first. So Hamilton's equations are what? q1 dot equal to del h del p1, this is equal to q1. From here we just simply calculate, and q2 dot equal to del h del p2, which is equal to minus q2. Therefore, and the second part of the equations are p1 dot, since this is equal to del, sorry, qk dot this equal to del h del pk and pk is equal to dot is equal to minus del h del qk. These are the equations. Therefore these four are the Hamilton's equations of motion. Now from this equation we can write dq1 dt equal to q1. Therefore if we take and just integration, then we simply get q1 equal to c1 e to the power t. Simply you can also get from this equation. From this equation we get the values q2 equal to c2 e to the power minus of t here, where c1 c2 are the constant of integration. Okay. Now also p1 dot equal to this one. Therefore we can write p1 dot plus p1, this is equal to 2a q1. So this is p1 dot plus p1 equal to 2a q1, and this is the form of what, dy dx plus py, this is equal to q, this form of differential equation. Therefore we calculate the integral equation, okay, integrating factor, and then simply integrate this one, and this is the integration terms, you can just see. So then, and here we put the value of q1. Okay, the value of q1 is what, the value of q1 equal to c1 e to the power t. Okay, so we put the value of p1 q1, this is equal to c1 e to the power t, and here simply put the values q2 equal to c2 e to the power minus t here in terms of this one. Okay, then simply integrate, we get the values of p1 equal to this one, a c1 e to the power minus t plus c3 e to the power e to the power t and e to the power minus t, and p2 equal to this one, b c2 e to the power minus t plus c4 e to the power t. Now p2 minus b q2 by q1, this is equal to, we just simply put the values and get this c4 by c1, which is equal to constant. Okay, that means what, the value you can check this calculations as your own. Okay, so this term is equal to a constant, therefore answer C is correct here. Now we comes to another important thing, is Hamilton's principle. I think I will cover it. Okay, just see it once. Okay, so for a conservative holonomic system, its motion from the time t1 to t2 is such that the line integral of what, s equal to t1 to t2, l is a function of these ones, with l equal to t minus b has the stationary value. Stationary means has the maximum, you can say also maximum value for the actual path of motion. S is called the Hamilton's principal function, and the principle can be expressed as delta of t1 to t2 l dt is equal to 0, where delta is the variational symbol or variation symbol. Okay, this is the Hamilton's principle, very important thing. Now we discuss the canonical transformation. What is the canonical transformation? This is also very important, and questions already comes from this topic. Suppose qk and pk, when we need to change the system, then we use the canonical transformation. Okay, there are various types of canonical transformation, so just see it once. So q1 q and pk are the old position and momentum coordinates, and capital qk and capital pk are the new set of that. मतलब क्या है, position coordinates and momentum coordinates. Let the transformation pk equal to pk function of p1 p2 pn, q1 q2 qn and t, and similarly qk. Okay, function of this. Now if there exists a Hamiltonian h dash in a new coordinate such that capital pk dot equal to minus del h dash del qk, these are the Hamilton's equations of motion, and this one. Okay, then where h equal to what, h prime equal to what, summation pk qk dot, that is the Hamiltonian of the new system, this is equal to this one, and l dash is substituted in the Hamilton's principle, then delta of t1 to t2 l dash dt, this is equal to 0, gives the correct or actual equations of motion in terms of the new coordinates pk and qk. Then the transformations, this transformation is known as the canonical transformation. And one very important term is that what, the Hamiltonian of a mechanical system remains invariant under the canonical transformation. This is very important thing. Okay, and we now show the question based on this notes or theorem, you can say. Okay, now just coming to that question. Now we discuss another important thing, which is generating function. What is that? For the canonical transformation, the Lagrangian L in Pk Qk and L prime in capital Pk capital Qk must satisfy the Hamilton's principle. That is, this is the Hamilton's principle L and this is the new ones L dash. So that, but L equal to what? That means from the definition of Hamiltonian, H equal to what? Summation Pk Qk dot minus L. That means we can write L equal to this one and L prime equal to this one. Now delta of, we just put this value in terms of instead of L and L dash. Okay, so this we get these two equations. Now subtracting this one to this one, we get what? We get delta of these terms. Now in the delta variation, delta ft dt equal to 0 means f equal to some dg dt. Okay, g is an arbitrary function. Therefore delta of t1 to t2 dg dt, this is equal to 0, but dg dt equal to L minus L dash or minus of L dash minus L, you can check that also, or dg dt equal to this one. Okay, so this function g is known as the generating function. I think you are not understand this. Now let us take an example to understand properly the what is generating function, what is another topics, and that's one. Okay, so here is an important note. This is the note which is very important, and we need this note to solve the problems of canonical transformation. What is that? The quantity pi dqi minus summation small q pi small dqi is, if this quantity is a perfect differential, then the transformation is canonical transformation. Okay, that means suppose there is I equal to 1 and I equal to 1 and 2. Therefore what happens if we write p1 dq1 plus p2 dq2 minus p1 dq1 minus p2 dq2, this quantity as a perfect differential, that is d of something. Okay, then the given or the given quantity is or the given transformation is canonical transformation. Okay, now let us take an example of canonical transformation and find the generating function also. So here p equal to this one and q equal to this one. Okay, so p dq minus p dq, that is capital and small. Here only one coordinate and a moment is given, only small p and small q is one system, and the another system is capital P capital Q, 1 and 1. If there are p1 p2 and q1 q2, then there are we have to write the summation first. Okay, so this is equal to p dq means half into this one and d of q, and we already know that d of q equal to this one, differentiation of tan inverse, so and p dq. So we can write half into p dq minus q dp minus p dq, which is equal to this one, and this is equal to minus half into d of pq, that is what, minus d into g, or you can also write simply dg, or g equal to plus functions or minus functions. This is equal to half into pq g. So this is the generating function. Okay, and since we can write the expression this one as the perfect differential, that means what, the given transformation is canonical. So these types of questions also may be asked in the question paper. This is also another important topics. And now one important thing is the necessary and sufficient condition on the canonical transformation is that the transformation is canonical is that the Jacobian, this one, that is del of q1 q2 qn capital, p1 p2 pn capital, and del of q1 q2 qn small and p1 p2 pn small, this is equal to 1. Okay, let us take just one example first that you can understand this topic properly. So suppose q1 equal to this one, q2 equal to this one, p1 equal to this, p2 equal to this. Now we have to calculate the Jacobian first. Okay, so the Jacobian, what, the Jacobian here del of q1 q2 p1 P2 by del of Q1 Q2 P1 P2. This is the Jacobian term here. Okay, so this is equal to, you can write del Q, del capital Q1, del Q1, del capital Q2, del Q1, del capital P1, del Q1, and del capital P2, del Q1, and del capital Q1, del Q2, del capital Q2, del Q2, del capital Q1, del Q2, del capital P2, del Q2, and these terms, there are 4 terms also, you can check. This is equal to del P2. Okay, so now we put just the value del capital Q1, del Q1, this is equal to 0, 0 minus 1 by 2 P1, 0, 0, 1, 0, 0. We just calculate these terms from the given expression or given transformation. So this is equal to this one. Now if we express the determinant by using this quantity, then we get what? And first take common the 2 P1 terms. Okay, so we can write 0. Oh, sorry, if we express the determinant with respect to this term, okay, then we can write 0, this one, we express this with respect to this term, okay, 2 P1, then we can write this, which is equal to 2 P1, and then express with respect to this one, then we get what? 0 into minus so simply 1 by 2 P1, this is equal to 1. That means the canonical transformation which is given above is a canonical transformation. Based on this, also question comes in WBSET 2022. One question comes. So the questions I already solved like this: q to the power m something, what is the values of p, m and n. Okay, so this question based on this concept. Okay, you can check the question, and I already solved the question. मैं यहाँ पर जो WBSET प्लेलिस्ट का लिंक नीचे दे दूंगा एंड ऊपर भी दे दूंगा आइटम में, ठीक है, तो यहाँ से मिल जाएगा. Now properties of canonical transformation, these properties are very important also. So here you can, if you see the questions paper of West Bengal SET exam, then you definitely, I can definitely say that questions you face in the question paper, and the concept you need to solve the question paper, I already solved this, or I already covered the concept to solve the questions. Okay, so if the content helps you a little bit, then please give a like to this video, share with your friends, and subscribe the channel obviously. So the properties are: number 1, the set of canonical transformation forms a multiplicative group. Suppose there are some options, you can check, or you can took the correct one and one statement like this. Okay, then this may be a questions paper. This type of questions asked in the exam. Okay, and the second one is gauge transformation. In electrodynamics are types of canonical transformation. 3 is point transformation, is also a canonical transformation. 4 is identity transformation, is also and canonical transformation. Contact transformation is also and canonical transformation, and there are various types of canonical transformation in this topic, but I will not go to the deeper section of the canonical transformation, because this is a huge big chapter. Okay, I just take the important part. I again say topic. Now the question comes in WBSET 2020 paper. Therefore in this question paper we already solved the questions paper also in this session. Okay, so state which of the following is not correct. Point transformation is also canonical transformation. Yes, this is correct. Therefore we have to find the not correct. Okay, so there, this is not answer. Contact transformation or canonical transformation is extended phase space, and the definition of contact transformation is regarding this term. Okay, extended phase space, we calculate the we define the contact transformation in the extended phase space. This is also true statement. Gauge transformation or canonical transformation, yes, this is also true. Therefore these 3 are false. Under canonical transformation, the Hamiltonian equation need not be invariant, but no, under canonical transformation Hamiltonian equations are invariant. I already read, or I already write, I think here, where here, this one, Hamilton of the mechanical system remains invariant under canonical transformation. Therefore the questions now occur in the exam. Okay, Therefore the incorrect option is here option D. Okay, the correct one answer. Now one more important topic, which is Poisson bracket in the mechanics. This is also important topic. The Poisson bracket we define here the functions f and g dependent upon p, q, k, pk and t. Then by the Poisson bracket between any two dynamical variable f and g is defined as bracket of f and g. This is equal to summation I equal to 1 to n del f del qi del g del pi minus del f del pi and del g del qi. Now fundamental Poisson bracket, this is a definition bracket of qk ql. therefore q and q का जो bracket होगा वो 0 होगा, p and p का जो bracket होगा वो 0 होगा, वो भी 0 होगा, and p and q का जो bracket होगा वो delta kl होगा. That means what? If we write qk pl, suppose this is equal to 1 if k equal to l and 0 if k not equal to l. This is the definition of delta function. Okay, this is the definition of fundamental Poisson bracket. Properties of Poisson bracket: what? F is equal to 0. Number 2 is f c equal to 0 as c is constant. Linearity property a1 f1 plus a2 f2 into comma g, this is equal to a1 f1 g plus a2 f2 g. Number 4 is f1 f2 g, this is equal to f1 into f2 g plus f2 into f1 g. Jacobi's identity, this is very important. Okay, f g h, this is the bracket, these are the bracket, then this three sum term is equal to 0. The sixth one is del t a into fg, and that is if we take the derivative, then this is equal to del f del t g, that is first term derivative plus first term. This is simply rules like product form of derivative. Okay, this one. And 8, suppose d dt of fg, what is occurs? Fg. So df dt g plus f dg dt, same as that in the del t of the bracket. And f pk equal to del f del qk. F pk, this is equal to del f del qk, and f qk equal to minus del f del pk. These are the properties, and these properties are very important, and when we have to calculate any problem, then we need these properties. Okay, equations of motion under Poisson bracket: qk dot equal to minus del h del pk, that is qk dot equal to minus h qk, and minus h qk equal to qkh, we can write. This is the important thing. And pk dot equal to pk into h. Now Poisson bracket is also invariant under canonical transformation, so this is also very important line. Okay, now if we take an example, a particle of mass m is acted upon by a central force, find the equation of motion. And we can take the x0 p0 as the initial values. This is just an example I take here. Now the Hamiltonian under this part, if the particle of mass m acted upon by a central force, then the Hamiltonian of the above system we can write here p square by 2m minus f into x. F is the force, okay, and x is your product term. Now dx dt, this is equal to what? X and t, dx dt. Okay, so from the equations of motion we can write dx dt, then this is equal to x into h from the this equation, since x is a position coordinate, this one, and xh we put the values x and h means this one. Now this is the linearity property, we use here the linearity property. Okay, and then 1 by 2m common, this is also the this property f of ch, I think this one is the property. There is the properties we can use here. This is equal to 1 by 2m into x p square minus f into xx, this is equal to 0, and since qk equal to 0 we already get, so this is equal to 1 by 2m into 2p. This 2p comes from where? From the definition of Poisson bracket. What is the definition of Poisson bracket? Fg equal to this one. Suppose if there is no summation, then that is what? There is what? Fg equal to del f del qi and del pi. Okay, so from the definition of Poisson bracket we can write here del f. So suppose f equal to x here and g equal to p square here. Okay, if we calculate the Poisson bracket fg, then Poisson bracket fg equal to what? Del f, what? Del f del qi, here only one coordinate, del f del, therefore del f del qi means del f del x del g del p, I think x and position and momentum coordinate, okay, momentum coordinate del p del g del p, okay, plus del f del p into del g del x, okay, this is the Poisson bracket. So del f equal to x, we just put del x, this is equal to 1, and del p square by del p, which is equal to 2p, del plus del f del p, this is equal to 0. So this means 1 into del p of p square means 2p, okay, this 2p comes here from the above bracket, okay. So this is equal to p by 2m, okay, since xp equal to 1, okay. Now similarly we calculate the d2x dt square. Here dx dt, d2x dt square means we can write what, d dt of dx dt, and d dt of some terms is equal to dt this and h from the above given equations, this one qk dot equal to means what, del t of qk, this is equal to qkh. Therefore we write similarly here in the pattern, here del t, here del t, obviously del t of this one equal to this, and we put the values of dx dt, we just get from the above this one. So we put this value, and after calculation similarly you can calculate this calculation, and we get f by m, and then next derivative term is equal to 0, and therefore the next higher order derivative term also 0. We get if we get one, what, just a second, if we get one derivative is constant, see this d2x dt square, this is equal to f by m, which is equal to constant. Therefore the higher order derivative term 0. Therefore we don't need to calculate, or don't need to proceed further, or don't need to calculate the higher order derivative terms, okay. So, and if you, I think you can calculate this under Poisson bracket after using the properties and the definition of Poisson bracket, okay. So x equal to what, we write the equations like this, x equal to and p equal to, this is the calculations for x. So x equal to, x0 means initial term, so x0 plus this what, this one p0 by m into t, since the equations of motion is based on two variable, time variable and the position variable. Here only one position variable, which is x, this is into t plus f by m into t square. If we get another terms, the derivative terms, then we also write the coefficient of the derivatives and t cube by 3 factorial like this, okay. This is the equations of motion. You can say this is like the Taylor series expression, okay. This is the coefficient and this is the derivative terms. And similarly we can calculate the derivatives for p, dp dt and d2p dt square, and we get here already dp dt equal to constant. Therefore we don't need to proceed further, that is we don't need to calculate the higher order derivative terms of p with respect to t, okay. So this is equal to simply p equal to p0 plus f of t, okay. So this is the class, or this is the content for classical mechanics for WBSET exam, okay. And we already with PYQs, we already discussed the PYQs of some exams, okay. So if you like this content, or if this content is helpful, if you think that this content is helpful for me, then please give a like to this video, share with your friends, and obviously subscribe the channel. And if you need another topic, or if you need another concept of mechanics, you can, or if you think that this topic is helpful, I skip that topic, yes, this may happen, okay. So then you can comment me in the comment section below, okay. So thank you friends, see you again in the next video, thank you.